All right, why don't we go ahead and get started, Jim? I'm going to let you open it up. I'm going to close this from a video perspective on me, and we'll go from there.
Fantastic, Bill. I want to thank you for participating in the Breathe Easy Indoor Air Quality webinar. My name is Jim Axel. I am your VP of Sales for IHS. Just to let you folks know, we have had many customers that we service with our sanitizing and disinfecting products that have asked us about indoor air quality and what could we do to recommend a solution for them. Well, about 9 months ago, we started down the track to review different products that were on the market. And it quickly became clear that some of our customers, or the reason why our customers were having issues finding good quality products, because there were many products out there that quite frankly were snake oil. Fast forward to today and the webinar that we're about to do here, we found a solution that is absolutely, in our opinion, the gold standard when it comes to indoor air quality. And it's a product that we can stand behind to provide to our customers, and it complements our existing portfolio. So with that, I'd like to turn this over to Jesse and let him get started with the presentation. Thank you very much. Also to let you know, this presentation will be recorded. This webinar will be recorded and will be provided back to you after the session. Thank you.
Thanks, Jim. And good afternoon, everyone. Thank you for your time this afternoon. I'm going to make a quick introduction of myself and then introduce you to my colleague, Tim Campbell. Jesse Coro, Director of Health and Healthcare at Lab. I've been with Lab for a decade. Part of my history is providing solutions to improve the air we breathe, mainly in the laboratory sector, but now in the commercial markets. Our company, Lab, has been dedicated for over 53 years, providing solutions to mitigate the risks of emissions, whether it be on the chemical side or bioaerosol side, which we're going to talk about specifically today. But I do want to introduce Tim. He's on the call. I'm going to spotlight him from everyone just to show you a little bit about what we do and who we are as a company, so you can understand that we're not a fly-by-night company or part of the snake oil that unfortunately exists due to this tragic pandemic. Tim, do you have access to the Inspiration Center you can show folks?
Yeah, let me see, get over there.
He's going to take you for a little tour of our inspiration room.
Yeah, we do have people presenting in there. I don't know if you can see behind us. Behind them, those are our ductless filtering fume hoods, where our filtration technology comes from.
Yep. So we're presenting right now in front of some architects and engineers to help them design their laboratories. So again, we're committed, we're dedicated. This is part of our DNA, what we're going to discuss today. So let's get to it. Let's clear the air, everything you need to know to make the right decision for schools and the improvement of your indoor air quality. So a couple did you know facts that I'd like to run by everyone before we get really deep into the presentation is truly understanding the impact the air we breathe has that many people don't understand. First, start off with, we breathe 8 to 10 liters of air per minute. I'm just going to stop my video just so I don't lose bandwidth here. With every breath we take, we breathe in 3% of someone else's air in a communal setting, which is why with bioaerosols and infectious diseases such as influenza, SARS-CoV-2, MERS, RSV, you see transmission happen mainly in schools, long-term care facilities, where you have a heavy concentration load or occupancy density. We're breathing bad, polluted air. And with 90% of our indoor time spent indoors, it's critical to address the source. The source of the problem is indoor spaces. Poor air quality contributes to over 6 million premature deaths per year. That in and of itself is a pandemic that we must address. Indoor air is 2 to 5 times and sometimes even 100 times more polluted than outside air. Why is that? Well, it's because we don't have adequate ventilation measures. We're only bringing in potentially very polluted air from outside into a concentrated place of business or our academic school of learning, or daycare centers, and this bad air just propagates and the concentration continues to exist and propagate over time, which makes it more polluted than the outside air. The EPA ranks indoor air quality among top 5 environmental dangers. Again, something we must address, something we've known for a very long time. Fortunately and unfortunately, the pandemic has really brought to the forefront of the critical nature of this situation. And as we've learned, higher the particle load present in a room increases the risk of infection from airborne bioaerosols. And I'm going to talk about particle loads and exactly what that means a little further on in the presentation. But you can also see in this slide the percentage of the significant long-term and even short-term health effects that indoor air quality or even just bad air has on our health, from COPD death, cardiovascular death, neonatal deaths, lower respiratory infection and death, which we've unfortunately seen, stroke. I mean, these are some things we don't think about when we breathe air, is it can contribute to my overall heart function, my overall brain function, cognitive abilities. It has a major impact. Why schools though? When we started providing our Halo, which we're going to talk about as a solution to the commercial sector, specifically Head Start Title I and K through 12 districts, as well as long-term care facilities, we really wanted to understand why the risk was so great in some of these facilities. Well, with schools specifically, you have to understand you have a high load of concentration of people continuously breathing and expressing out bioaerosols, whether it be just regular coronavirus, cold, influenza, RSV, norovirus, whatever it may be, it continues to release, that emission continues to release, and you have high concentration loads existing. And because schools mainly were designed with poor indoor air quality in mind in the 50s and 60s, they don't have adequate ventilation, which is one of the main reasons why schools, K through 12, again, Title I Head Starts, tend to be a huge, huge issue. And we're seeing the same issue of concern in long-term care facilities, which is why you saw, unfortunately, such a high spike in infection rate and mortality rate in LPC community. So again, we must reduce these risks. And if we can do so efficiently, we can reduce absenteeism, improve work performance of the students and the staff. It makes the air healthier to breathe, therefore making them more apt to want to stay and be part of your organization over time. You protect the students, and the air that feels easier to breathe means you have a happier and healthier environment. And we have a phenomenal case study that I'm going to present to you at the very end of this presentation with an installation we just did at the ARC up in New Hampshire, which is a Head Start district. They have 3 locations, and we're going to show you the reduction. And I'm going to talk about some of the quotes that we received from the staff and parents. So when we talked about particulate load earlier on in the presentation, we have to understand what that means. Particulate matter means it's the size of the particle in diameter and the concentration of that specific particle matter that exists in the room, again, significantly impacts our overall health. But the particle that we have to be really concerned about is called PM2.5. So that's particulate matter between 2.5 micron in size and smaller. And if, as a reference point, human hair is between 50 and 70 microns. Dust and pollen, which you see and you wipe down and it's gross, you don't know how it continuously ends up on your surfaces, that's PM10. That's about 10 micron in size, and beach sand is about 90 micron in size. But the dangers exist at that PM2.5 and below. A virus itself is about 0.1 to 0.5 micron in size. So extremely small and extremely challenging to capture. But because these particulate matters are so small, when we breathe them in, they go deep into our lungs because they bypass our mucous membranes. So they go deep into our nose and our throat, and they penetrate deep into the lungs, which is why they exacerbate the chronic diseases I mentioned earlier. And in fact, exposure to PM2.5 is linked to higher, unfortunately, COVID-19 infection and mortality rates, and that's right off of the NIH website. So again, it's something that we must address but not just for viruses. It's just overall health, overall indoor air quality, asthma, other breathing issues, skin irritation, headaches. All of that is very impactful. So now we have to understand our risk, which we do, the air we breathe, and we have to understand why a virus propagates over time and why it's so important to capture it the way I'm going to talk later on in the presentation. When we first got hit with this 24 months ago plus, first it was about formite transmission, stay 6 feet apart. If you do that, everything's going to be okay. Unfortunately, that's not the case, and we've learned a lot over the last 2+ years. When we release any type of virus from our respiratory tract, it's known as droplets. When you cough, sneeze, talk, these droplets are heavy in size and they fall and they want to go to the surface. These droplets desiccate, basically dehydrate over time, and they become smaller infectious droplet nuclei. That's what we're looking to capture. That's the biggest risk factor of a respiratory illness. These droplet nuclei remain suspended in the air between 3 to 7 feet up, and they just propagate over time, and they create a high concentration load of infectious droplet nuclei. And we need to figure out a way to mitigate that effectively and drive these infectious particles as well as other PM2.5. So all these small particle matters I mentioned, they're going to propagate as well. We want to drive them away from the critical breathing zone. But we do know that the successful equation for infection for any bioaerosol is exposure to the viral load concentration over time. So if we can mitigate that effectively and efficiently, we've just developed a strong mitigation strategy for your facility. So let's get familiar with some of the CDC and ASHRAE guidelines for indoor air quality, because it's important. And I know there's been a lot of information presented to you over the last couple of years on what we need to do to reduce our risk factor. CDC has come out with guidelines. ASHRAE, which is the Committee for Heating and Air Conditioning, has also come out with guidelines. But unfortunately, there's no standard. What we're looking to do and what we have done is actually set the standard of what needs to take place. And we're working with legislation to get standards written. Unfortunately, that takes many, many years to do. But let's go through some of the guidelines that have been set by CDC ASHRAE. Obviously, many of you have probably heard increase my outside air. What does that mean? It means bring more fresh air into my facility. Well, the first question that many people have is, how do I do that with my current system I have in place? How do I increase my outside air? More often than not, you can't. Your building's just not compatible. Your air handling unit, so to speak, your HVAC system is not compatible to increase my outside air. And then if I could, that's going to add significant operational cost because of heating and cooling loads that are going to be added to the facility. But then they also want you to increase MERV 13 to MERV 13 filters if you can within your HVAC system, so that when the system's on, you can capture some of the viral load within those filters. They want you to reduce or have your relative humidity between 40 and 50%, because that's a real healthy, what we call RH load. And again, upgrade my ventilation in HVAC. These are just the guidelines that are set in place. And of course, social distancing and masking. But these guidelines that have been put into place are unfortunately not achievable for the majority of the facilities we talk to. So let's talk about some of these other solutions that are available. And unfortunately, the snake oil that does exist, and understand the true effectiveness and efficiency of some of these technologies. But I do want to take a step back and again understand load and airflow movements and airflow dynamics, and again how important it is to capture these emissions and up and away from the breathing zone. And even as you see here in these diagrams, obviously if you don't have a mask, you're releasing greater load, but even if you have a mask on, you're still releasing significant loads. You just don't have an N95 mask. It's not possible. And in many of the facilities, the folks that are on this call today, they're the children cannot wear masks. It's impossible to ask that task of them to do. And then you have, this diagram here that shows you an air cleaner, a HEPA filter system. But what good does it do when you're releasing bioaerosols and you have a heat load wanting to drive those propagated emissions up anyway? We'll touch on that in a moment. But I do want to touch on this diagram to the right, where you have patient 0 in a school district, which was a teacher that was positive for COVID in May of 21. And you had an air filter next to the teacher desk. You had all the students. Well, as you can see here, this air filter did nothing. It's a floor mounted system. It literally blew around these bioaerosols throughout the whole classroom. And you can see over time how it impacted almost every student in the classroom all the way to the back of the room. Why was that? If they had an air filter, aren't we cleaning the air? The answer is unequivocally, you're not. You're actually blowing around these emissions, and then you're increasing the concentration load to people away from actually patient 0, where the emissions first existed. And why is that? Again, you can see here, it's just blowing air. It's just blowing air around. It's not really capturing the source of the issue. And you have the thermal load, the thermal plume that exists from the human body, which is about 75 watts that we emit of thermal plume. What happens when you heat anything up? Heat rises. So why would we want to drive all of this harmful bioaerosols down to the breathing zone of your students, your teachers, whoever it may be, all the babies crawling around on the ground, and then trying to get it to a little mini air purifier, maybe even a larger air purifier in the corner of the room or at the back of the room, where you're just going to increase the concentration load to the kid, to children and staff, when we can just come up with a solution that works with the thermal load to drive these emissions up and away. So let's do some homework and again, talk about all these different technologies. And the purpose of my presentation to everyone on the call is just to educate you on what the right thing to do is. And again, we know a lot has been thrown at you and everybody's trying to do the right thing, and we understand that. So if we can get one thing out of this presentation, it's a takeaway of being educated on the right solutions and not being fooled by the unfortunate charlatans that do exist. And I say that because, hey, I do my homework. I've researched these companies online. They have beautiful websites and they all say they're 99% effective. So it must work. We only know what we know. And we only know what we told. If you invest enough in marketing dollars, you can make anything look good. So let's dive a little deeper into these technologies. The first is UV lighting or upper room UVGI. We've seen this implemented in many different ways to Sunday. You have upper room UVGI, you have UV lights in your actual lighting fixture, which is an absolute no-no. So let's talk about what this does. In a setting, like many of you on the call, it does nothing. Upper room UVGI, it is a technology that works when applied appropriately in the right type of setting. It was initially designed for tuberculosis rooms. In these rooms, in these hospitals, which is a controlled environment with controlled airflow, they ensure that they have the proper airflow dynamics to take the polluted air from the patient and then drive that polluted emission up near the ceiling where the UV light shines for enough time for the dose, the exposure dose, to occur over time to deactivate any type of the microorganism that exists in the air. And it's a continuous process. It works effectively in the right setting, but you must have the proper airflow. So certainly not the right technology for most of our clientele. Again, in a hospital setting, in a controlled environment, it works, but not in this setting. Then we have ionizers. This is one that we've seen, unfortunately, installed in many school districts. And now a lot of these companies are under litigation because of their false claims. And what do they claim? They claim that you can put a charged ionization system at the air handling unit where the air blows out of, takes you from the air handling unit, takes you through the HVAC system, and then it's going to disperse all these negatively and positively charged ions throughout the facility and in the rooms. That doesn't happen. Again, a technology that works when applied appropriately. This was initially designed for a controlled chambered atmosphere, such as an ice machine, or even inside of the ductwork, where it can deactivate any type of bacteria, funguses, or viruses on the heating or cooling coils, or even the filter. It does not provide air filtration. How can it? Why would you want to add an additive to anything when you're trying to get rid of any potential additives that exist? And in addition, these has unintentional consequences, such as creating byproducts like chloroform, formaldehydes, or even ozone when these positively and negatively charged ions connect with some of our own human organic matter. So again, must apply the technology appropriately. And then you have floor mounted units. I've already discussed this. These are very frustrating for all of us on the call here, Jim, Bill, myself, and Tim, because of course you can buy these at Home Depot, you can buy them off Amazon, you can plug them in and you can say, hey, I'm doing what I need to do because it says it's 99% effective. But when you understand, again, how viruses propagate, this isn't just viruses, this is the PM 2.5, bacteria, fungus, just the bad stuff that we don't want to breathe. Why would we want to drive that down below the breathing zone? This is intended for residential use, where you're trying to capture pet dander, pet hair, dust, mites, particles, things we talked about earlier at that PM2, PM10 range. These are not intended for bioaerosols, bacteria, and fungus that are airborne. Again, it's made for residential use, but there's a lot of these systems out there. Please be careful. I already showed you that diagram before. There's another floor UV unit, which we've seen, and unfortunately for this company, they're also under litigation because they intended to sell this unit as a bypass UV deactivation system. So meaning you blow air through, you capture it, and you have the UV light deactivate any air that bypasses through the system. Well, that can't work. UV lighting, you have to have a certain amount of dose of that light over time to have proper deactivation. And in fact, the Sacramento City Unified School District purchased, I think, $2.5 million worth of these products. And after further investigation, they returned them to the supplier and said, these don't work. I don't want them in my facility, because they don't. Again, another snake oil that was sold trying to make a quick buck. And one other question we want to ask ourselves when we're looking at a solution is, where were these companies and who were they selling to before this pandemic? There are a lot of companies are trying to capitalize on this situation. It was never Erlab's intent to focus on the commercial sector, but reason why we did is because we saw what was going on, and we quickly realized if we can just be the voice of reason, then we've done our job. And again, that's what we're trying to do here. And then the next technology, which is a tried and true technology, ventilation. If I can increase my ventilation rate, I add MERV 13 filters. I'm going to talk about the filters in a little bit more detail in a second. We talk about MERV and HEPA, what's the difference? But yes, ventilation always works. If you can add ventilation rates, or what's known as air change rates, to your facility, by all means do it. But understand, it's only effective when the unit's on. So if you increase your filters, even if you increase your outside air, you're only capturing and diluting any potential contaminants in that room when the system's on. A typical HVAC system runs 15 minutes an hour. So you're allowing concentration to exist for 45 minutes at a time. That's enough time for concentration to have that equation of infection. So yes, it works. It's very costly if you want to run it even throughout their 8 hours or 12 hours a day consistently. We worked with the school district in Massachusetts that did this. They improved their ventilation. They added a couple $1 million of upgrades to the HVAC. And when they turned that system on, they ran it throughout the school day, their energy load consumption went from about $13,000 a month to about $38,000 a month. It wasn't sustainable. So they had to back off on the number of air changes that they had this very expensive system do. Basically, they spent a lot of money for nothing. So it works, but understand the challenges in the operational expense with the upgrades to the HVAC. And okay, so let's talk about the different filters: MERV 13, MERV 11, and HEPA filtration. You may even heard MERV 7, which the vast majority of your facilities have. It's basically the efficiency rating of the filter. How efficient is this filter at capturing particles? Well, as you can see, the lower the grade the MERV filter, the less efficient that filter will be at capturing these very dangerous particles. When you get into the HEPA filters, that's when you become 99.97 or 99.9995% efficient. That doesn't tell the whole story. A HEPA filter is only part of the story. You need to make sure you have a very robust system that can that's commercial grade, that has high capacity loads, that can capture the right amount of particles and have a great efficiency rating. But that's only part of the story. If you have a great HEPA filter in a floor mounted system, we learned from the previous slides, what good is it if it's just blowing around the air? You have to understand proper airflow dynamics. I'm going to touch on that in a moment, and work with the thermal plumes like we discussed earlier. The other bit of technology is induct UV. Again, think about that term induct. It's only going to deactivate anything that goes into the ductwork at the heating coils or even at the filter. It does not address the room air. Plain and simple. And then you have large room UVC. You see this a lot in locker rooms. We have seen it in schools. You see it a lot in hospitals. After you've had an episode, or even if you just want to do a deep clean of the facility, you put these UV, big, huge robots, or even these roll-in UV lights in a room, and you run it. Has to be unoccupied. You cannot have any occupants in the room when you do it. And it runs it for about 10 to 20 minutes. So you have the proper dosage time to the lighting to deactivate any type of contaminants. Unfortunately, with UV lighting, if you have any type of shadowing that exists, even a dust particle, you're not going to deactivate that surface or decontaminate that surface. So it only works and it is effective where the light hits it at the specific wavelength, which is typically between 222 to 256 nanometers. In layman's terms, that's the wavelength of the UV light and what's needed to deactivate any type of surfaces. So it can be effective, but understand it does have challenges, which is why we personally love the Zonos machine that IHS provides, which I didn't know about until I met IHS, because it makes sense. You put your high area or high functioning areas that have a lot of touch points into the system, and again, use ozone or ionization appropriately. It works. You don't have to worry about shadowing. And then you have chemical fogging. Please, if you're doing this, please stop. This is extremely risky. As you can see, the poor guy spraying the fog is wearing his own hazmat suit. Why is that? Because you don't know what the impact is of these chemicals being dispersed within the room. And in addition to that, again, it only can be done under unoccupied situations, which means if you have anybody present in that room, first and foremost, please don't. But if you do, they're going to be impacted by these aerosols that are distributed from this fogging system. And it's still not going to address the air that's breathed once you have the occupancy density load of children or staff members present in that room. It does next to nothing. If you're going to do anything like this, do the UV, because this has chemical residue issues. You have children putting toys in their mouths, whatever. Again, why we like the Zonos machine. Please, fogging is a no-no. Where you fog is in a pharmaceutical company where you can have proper pressure, negative pressure or positive pressure in that specific room where you're doing the fogging, and you have the proper air change rates. Laboratories are known for air changes. Some of them have about 20 air change rates per hour. So you can imagine they spend millions and millions of dollars a year in processing the air in that facility. That's when these systems work. You run the fogger, you shut the air system down. Then once it has the right contact time, which is about 15 minutes, then you can put the air change rates back on. And by the time people get back in the facility, they're adults. They're not going to be breathing these harmful emissions, and they're certainly not going to be licking surfaces, so they don't have to worry about chemical residue. So again, a technology that really eats us up a little bit here. So we've done our homework. What's the proposed solution? Well, one of the proposed solutions is our Halo, which is a ceiling mounted self-sustainable air filtration system working with airflow dynamics. Now remember the thermal plume that wants to drive these bioaerosols up. That's exactly what this system does. Again, we're in the lab world. We understand airflow. We understand how to capture very hard, volatile compounds such as formaldehyde, chloroform, everything I mentioned earlier, xylenes, acetone, IPA, you name it. That's the world we live in. So we understand how to control airflow, how to properly capture emissions effectively to allow for proper dispersion of particles or even chemical compounds, to use the whole surface area of the filter, and again, how to work with the airflow in the room. Now with that, obviously our system has an H14 medical grade filter. We only use the highest grade filtration. As you can imagine, we have to adhere to very strict guidelines ourselves, being in the lab world. But I'm going to stop my presentation here and allow Tim to do a very quick demo so you can see real time how the product works, how it's effective. This isn't a time-lapse video. He's going to do a smoke test demonstration so you can see what happens in a room that has static or stagnant air. And then what happens when you put on the halo and you have proper airflow, what's known as the Coulomb airflow effect, and then capture efficiency. Stop it. And Tim, I'm just going to put you on here.
All right. As you can see, the halo is suspended from the ceiling, which gives it or allows it to provide the optimal airflow patterns for increasing ventilation effectiveness and mixing more air within the room. Right now it is currently off. I'm going to release a little smoke and you'll see how it kind of just sits in the middle of the room about breathing zone height. Release it now. So that's a very high concentration. You'll never have one person releasing that much at a time, but you see it kind of sits. It does rise, as Jesse mentioned in his presentation. It's basically hot as it comes out. So this room's cold. So it does naturally rise, but you see it just floating there. There's no ventilation in this room. It's not mixing. It's not moving. I'm now going to turn on the halo and you'll see the smoke be pulled up towards the halo, and then it will start mixing the room air.
And you can see while the halo's coming on here, the light turns on. Why would we want to bring these down to the breathing zone? It doesn't make any sense. And you'll see how the halo is effective at, again, driving that air up. So as the halo ramps up, the light above it will come on. Tim, the floor is yours. Sorry.
Yep. No, you can see, if you can see in the video, the smoke is being pulled up towards the HEPA filter. So the whole plume of air is moving up. Clean air is being returned on the side of both sides of the unit and is circling back down underneath to then grab any smoke that it hasn't gotten to bring it towards the HEPA filter. So with it being overhead, the halo brings more air in the room to the unit and through the HEPA filter. That's the only way it's going to be cleaned with any device, is getting the air to the device. The halo is the best at doing that. Now, within a few minutes, the whole room is going to be cleared out. The smoke will be gone as it continues to mix the room air. So any concentration is diluted and then captured by the HEPA filter. And then I'll do another dose with the unit on, as you saw that cleared out. And now, instead of just sitting about breathing zone height, you can see it's being pulled up. Some of the smoke is being moved around, and that's just with the airflow pattern. There's much more air moving around the room. So it's going to circle back around, go through the HEPA filter, be captured, and then clean air will be returned back into the room.
Perfect. And as you can see, this is a challenge test, so you're not going to have that much load at one time, but just shows how impactful the system is. Thank you, Tim.
You're welcome.
All right, I'm just going to put the presentation back on. All right. So now, of course, we work for our lab. I have a vested interest in the company. Of course, we can say the technology is great. It works. It's everything we deliver. It provides effectiveness and efficiency. But that doesn't tell the story. It's better off to hear it from the mouth of users, and that's really what we've done here. We obviously had to challenge this system to understand the effectiveness of capturing bioaerosol specifically, but we also wanted to give you real world data, which is critical. You can make any device look promising and look good in a controlled atmosphere. Of course, that's easy to do. But when you have the unpredictability of airflow dynamics in a moving room, such as that of a Head Start or a daycare, K through 12 school, it's very challenging to do. So what I'm going to show you here is first control studies. You can see the effectiveness when we've done this at a BSL room and through third parties, but also pre and post validation. So what does the system do once installed? And what we do is we take particle counters, we take them to the facilities in which we know we're going to deliver Halo systems to, and we run pre-validation testing of the particle load present in the room. And we print out the results, we take counts right in front of the user, and we show them, this is how many particles we've counted in the air. Now, those particles can represent viruses, bacteria, fungus, just general particulate matter. We don't really know, but it doesn't matter. We know there's a high load of concentration of particles. And the more particles present in the room, the more transporters you have. So basically think of a particle as a taxi cab. You have more particles floating around the room. You have more taxis for the viruses to latch onto, or bioaerosols to kind of travel through the facility. So we want to just get rid of as much as possible. So then after we do that testing, we install the halos and we do a post-validation test. Now, again, we set ourselves up for failure because we can't control anything. So we go there real time, we take counts, and we're at the mercy of what this particle counter tells us and tells the user. And those are the results you're going to see, and those are the meaningful results. So let's touch on that real quick. And we've done A/B testing. So A and B testing means before and after. So these first few tests that you see here are controlled studies, and we wanted to know, what the Halo does, how effective it is it at reducing viables, which are living organisms. And we used MS2, which is a surrogate for influenza and SARS-CoV-2. We did this at a company called ARE Labs, where they have a BSL chamber where they test for all kinds of bioaerosols. So it's a very strict chamber. It's about 200 square feet. So it's small, it's a chamber, but you want to see what the log reduction is over time. And log reduction is a fancy term of the percentage reduction of pathogens. And what you want to establish is, a log 4 reduction over time, but a log 1 reduction obviously is very good at 90%. And what we were able to see out of these studies was a log 1 reduction within 15 minutes of operation. And this is continuous emissions of bioaerosols released in this chamber. And this is over a 90-minute span. And then within 45 minutes, we got to about a log 3. And then within 60 minutes to 70 minutes, we got to a log 4 reduction. Great, 99.99%. Fantastic. What does the system do in a real world setting? Now, this next set of data is just that. So these charts, the blue line are pre-installation, the orange lines are post-installation studies. And this was done at a shoe warehouse, Foot Locker. It was WSS when we did the reports. Now it's Foot Locker. I know it doesn't really pertain to your market, but nonetheless, a large warehouse space. And they wanted to install halos because they wanted to prove to their staff and their employees that they have a safe environment in their customers to come into. They only install 10 units. They have 180,000 cubic foot facility. We recommend about one Halo every 10,000 cubic feet. So they installed about 10 units. We were expecting to see a reduction, but we didn't know what to expect. Now, a third party AABC testing performed these validations, and what we came up with at the end of the test data was an average reduction of 80%. And that's for the particles that we're very concerned about, between 1 micron down to 3 micron in size. Again, real world data. Then we had community chapel with a youth group. Again, they're down in the basement, so they had very poor air quality to begin with, and they installed 8 units themselves. We wanted to see what the reduction is. So you see pre and post counts here. So the yellow are pre-counts. So that's 2 million particles at 0.5 micron, 650,000 microns at 1, so on and so forth. And our average reduction was about 75% within that facility. So again, significant reduction. Then this is pretty interesting. We're going to get to long-term care. We wanted to actually test for COVID present in the air. So this next testing was just that. Very challenging to do, as you can imagine, all the chaos that's been going on in the LTC community, but we were able to achieve it at Avamere Healthcare Associates. We installed a halo in a patient's room, and then the patient room adjacent to that room did not have a halo. Now, both rooms were known as isolation rooms, so you had to be COVID positive to be put into these, unfortunately, isolation rooms. The patient in room 120 with the halo was at the beginning of their quarantine. Patient in the room of 118 was towards the end of the quarantine, which means patient in room 118 was shedding much less viruses than patient in room 120, which was proven by the testing you can see here, where it says floor, window shelf. We did PCR testing swab samples to see how much viral load was on the floor and on the surface of the window shelf. And you see patient in room 120 was just shedding a tremendous amount of viruses, 23,000 copies of RNA, 820 at the window shelf, whereas patient room 118, nothing. What we don't have is the cleaning log, so I don't know the cleaning log information here, but nonetheless, shedding a ton of virus, shedding next to nothing. What's kind of unique here, very unique, is that the return register, so the airstream, patient in room 118 without the halo, non-detectable at the surfaces, so we know they weren't shedding viruses. The virus was lingering in the airflow. We detected 3,500 copies at the return vent, which means it's just driving this bioaerosol throughout that room. Whereas the patient room 120 without the halo, non-detectable. Just again proves the effectiveness and safety behind it. Again, it doesn't really pertain to your specific market, but nonetheless, it's very good data to have. Now, the one we're very excited about, because we just performed this installation at the ARC, we were floored when we actually did the pre-install particle counts. And Danielle, the director, was with me during all these counts. This is just a Londonderry location. They had 2 other locations. But you can see from this slide, which room do you think was the sickest room out of all these counts? If you guess the one with 121 million particles, you're right. So as I'm taking particle counts, we got to the infant room. And this particle count is good. It's like Ghostbusters. The thing's just rolling. The numbers are rolling. And Danielle looks at me and she goes, "This is my sickest room." Well, here's why. Again, we don't know what these particles were. These are the commutative particles. So from 0.3 up to 5 micron in size. We don't know if they were viruses, bacteria, mold. We don't know. We just know there was a lot that existed. So I said, okay, well, we're very excited to get the results after installation. We didn't know what to expect. I expected about a 50 to 60% reduction just because it was so high. We went last week or the week before, I think last week, and we did post-installation counts. Here are the results, a 98% reduction just in that infant room. And you can see the results of all these rooms. The comments we received when we were there instantly was, "Thank you. This is what breathing clean air feels like. My room isn't sick anymore. I have less and less of my children sick, sniffling, sneezing. I feel better. I don't have headaches when I leave here. I can focus more." They were significantly impacted from the air they breathe. And this just proves how impactful it is to provide a cleaner environment for all. So very excited about that data. We will have a case story, and certainly Danielle will be a great reference if you want to speak to her. But in summary, we know ventilation is the key to mitigation risks. And if you can't improve your HVAC system, which many can't, you could have alternative solutions to add what's known as equivalent air change rates, but you must do it right. And again, you must apply technology the right way. And filtration can be that additive that, when used appropriately, can reduce high concentration loads effectively. And we also learned, unfortunately, while there are many options available, some that are very appealing due to cost, we know that we must look at all the data to determine the best solutions for our facility. Most of the data you'll find on these websites, it's going to be hard for you to understand where they collected this data and how they collected this data. So please do your homework, reach out to specialists. This is not a one-size-fits-all approach. It's a multi-pronged approach. It's truly a tailored approach based on your facility, and we will work with you to provide the right recommendations. So with that, thank you all for the call. I'm going to stop sharing my screen and allow this time for any questions.
So thank you, Jesse. Appreciate that very much. Folks that are on the call, if you would like to either go into the chat or the Q&A, we did have one Q&A during that time. Jesse was asking about how loud it was. I responded that it was about similar to a refrigerator, but I told him you would be able to give them the exact decibel level of that off the top of your head.
It's about 52 decibels. So yeah, it's equivalent to a refrigerator or a dishwasher running.
I did kind of give the analogy. We've had a couple of customers that say they love to have it during the nap time because the white noise really helps the kids to go to sleep. So I think that was kind of interesting.
A benefit we really didn't fit into the design, but hey,
No, not at all, not at all. So if anybody else has any questions, please don't hesitate to ask. We appreciate your time. We know it's been it's just Tuesday, but it's been a busy week for all of us already. We will have this available for those of you. We will be sending this out to you if you registered. And for those that weren't able to attend, we also will be sending that out to those that registered as well. So I'm gonna maybe keep it open once or twice here. And
yeah, anybody who has questions, just feel free to chime it. Put it in the chat because I don't know if everybody has access to their microphone. Sometimes these Zoom webinars get a little bit strange.
yeah.
So if you have a question, put it in the chat and I'll be happy to answer it.
I think that's it.
Well, there's one. Saw one question here, and this may have been as much of a comment as a question, and that is, so a child around 3 years old is most at risk since the average child is 34 inches tall. So that's, I guess, is speaking to the breathing zones.
Yeah, for sure. Children are at high risk, especially if you want to drive this down to the floor level. This is where the children are playing. You want to get it away from their breathing zone for sure. Okay. And the staff's at risk too, because these children, their thermal load wants to rise. And again, like I said, once the particles get comfortable, so to speak, they like to stay up in that breathing zone at 5 to 7 feet in the air. Now, not many people are 7 feet, but many people are 5 feet tall. And that's where the I call it the danger zone, because really that's truly where the danger zone exists.
I think that's it. We appreciate everybody's attention. Please don't hesitate to reach out to us via our website at www.ihcsolutionsUSA.com, or we have most of your names, and we'll be happy to get in touch and provide any further information if you'd like.
And there's one thing I'd like to $1 million question: how much does a unit cost? We'll address that in 1 second, but right off the WHO's website, I have article upon article here. Right off their website, 600,000 children died from acute lower respiratory infection caused by polluted air last year alone. And one reason why children are particularly vulnerable to the effects of air pollution is that they breathe more rapidly. We breathe about 8 to 10 liters as adults. Children can breathe anywhere between 15 and 20 liters of air per minute. So they breathe more rapidly, so they're more subjected to these respiratory illnesses, which is why they always have to wipe their nose, because they're just constantly breathing in this air quicker. Which means if we're breathing in 3% of somebody else's air with every breath, they're breathing in between 6 and 10%. So it's very impactful. And right off the WHO website, they also live closer to the ground, where some pollutants reach peak concentration at a time where their brains and bodies are still developing. Get it away from them. Get it away. And that's what we want to do.
Yeah, thank you, Jesse. And to answer Steve's question, the unit itself, Steve, runs at $29.95 per room. And typically, and what we've seen so far is that most, say 70-80% of the classrooms we've looked at are appropriate for enough air exchange that one unit makes sense. So figure about 1 unit per classroom. Now that $29.95 is for the unit. In addition to that is installation and then shipping. The nice thing though is that the installation is absolutely turnkey. We actually have electrical contractors all across the nation. We have them come in, take a look at your facility, identify specifically based upon cubic feet exactly how many halo units you need. They took a look at your electrical system. You don't need to go find an electrical contractor yourself. If things need to be done to your panel box, we can do those as well. And then everything completely is turnkey. It's operated, as was said earlier, by an app on your phone. So those teachers in the room can operate individually their particular unit. So it's works out to be installation for us so far has been anywhere from $500 to $1,000, to be honest with you, per unit. It just depends upon what your situation is, whether you're in a very old building and some things need to be upgraded, or if you're in a new school system building or whatever it might be. So that's why it's important for us to do the assessment up front and then be able to give you a final quote for that after that assessment's done. And you are not charged for the assessment if it doesn't go through.
And one thing that I would add too, that if you have resources there currently, if you've got facility resources, that type of thing that you want to utilize for this purpose, we'll work with you on that, and that would be able to reduce your overall implementation costs utilizing your existing resources.
Yep.
And, I like to add, remember, this is a long-term solution for a long-term problem. So this isn't just a quick fix solution for the issues we're dealing with today. We addressed it. It's just about air quality in general, not just about COVID. And unfortunately, and I hate to say these words, but there will be another pandemic. I don't know when, but it will happen. It's just inevitable. And we must be prepared. We must be prepared for what will happen in the future. But in the meantime, keep the air healthier that we breathe today.
And just wanted to also mention too, the cost of ownership. I mean, you covered,
Yep.
a little. It's pretty low. I mean, it's just like this Zono. There's very little maintenance is required. The longevity of these is way up there. So as Jesse said, it's a long-term decision. Put it in. Don't have to worry about it. Change the filters, and you're good to go. Okay, I think that's it. We thank you for your time, and look forward to hopefully being able to talk to some of you, as many as possible. Take care and have a great day. Thank you for joining us.
Thank you.
Thank you.